Hello, math students. Today we're going to be going over this Unit 10 activity, inferences and conclusions from data. Hopefully you learned a lot about how to do this sort of stuff, like how to interpret histograms and scatter plots and box and whisker plots and finding outliers and things like that. Hopefully you've done that already, but if not, don't worry about it. Hopefully this will make sense. This one, we're going to have to go to a few different websites and use Excel and stuff. But if you follow along closely and do everything I do, I guarantee it'll work out. If you don't have access to Excel, I'm going to show you some alternatives. Also, you can take some screenshots of my screen to help you out if needed. So anyway, your activity should look like this. There's a button in the top right corner that says Use Template. You should click on that. And then that should open the same thing, but in a Google Doc. And you can edit this Google Doc and then save it as a PDF and turn it in that way. So let's go ahead and scroll down, and you're going to see this first task here, the number of Hispanics or Latinos in the United States. And you can see there's separated into different regions, West, Midwest, yada, yada. Not a big deal here. The first thing we're going to have to open up is this data set right here. So when you click on this, go ahead and click on this, and it should open this first data set. And you can see it should say Hispanic or Latino population for the United States, regions and states, and Puerto Rico, 2000 and 2010. We're not going to really look at the 2000 data. We're going to look at the 2010 data. So we're really going to focus right here on this section of the data. So what does it ask us to do? So how do the columns titled number and percent of total population relate to the columns titled total? So basically you could see here that when I'm looking at this section, you see total here, then it says number, and then it says percent of population. So how did they get this percent of population? It's actually pretty simple. You take the number here and you divide by the total. So in this first state for Alabama here, we could take this 185,602, and you should have a calculator on hand, or you can Google a calculator or use your phone. But if you have a calculator, you should do 185,602 and then divide by the total right there. So 4,779,736. And you should see 0.0388. So what that is as a percentage, that's about 3.9%. So you can see down the line, that's how this is done. So when it asks, how do those columns relate to each other? Well, if you take the the number of people, number of Hispanics in that state divided by the total, that gives you the percent of the population. So just explain that there. And yeah, just as I explained right now. Okay, now here in this question too, it says generate a histogram of the state data in the columns titled percent of total population using the Histogram Applet. So if you click on this Histogram Applet, it'll take you to a Desmos page. And honestly, I don't like this applet at all. The problem says that you can copy and paste the information from the data table into the applet, but I've tried it a few different ways and it doesn't work for me. You can give it a try, but basically what they want you to do is to create a histogram out of this data, out of this column here. So for me, the applet did not work at all. So I would suggest not even using it. You would have to, go through here and put in all this information. It's not worth your time. So what can you do instead? Well, one thing you could do is you could take this data and you could just copy and paste it. So I would select this column, Control-C to copy, and then you can go ahead and use this website here, histogram maker here, social science statistics, and you can Control-V, paste, and it'll generate a histogram for you. Okay. This one works much better than the applet. But a couple things you might want to change. The number of classes here you'd put as 10. And then I think it looks best if you use the lowest class value of 4 or 0. Specify class range. We just want to say yes. The range we'll put as 4. Edit histogram, and you should produce something like this. So this looks much better, gives you some more information. Another option is if you have Excel, you can go ahead and take that same data. And what we want to do is create a histogram. So you can, the data is already selected, so that's good. You want to go to Insert, and then you go to Recommended Charts. You scroll down a little bit to Histogram, press OK, and there you go. You got a histogram just like that. And what they want you to do is take a screenshot of the histogram and put it into the problem so that that's there. Now, another thing, you kind of want to change the dimensions of this one as well. So what you can do is go to Chart Elements, go to Axes, More Axes Options, go to these columns, Axis Options, and then you want to go to Bin Width. And we probably want to go to 4. Number of bins, we're going to go to, 25 looks fine. These numbers all look funky, so whatever. But this gives you a good histogram that kind of shows you what's going on here. So yeah, a couple different options for creating a histogram. I suggest using Excel because becoming familiar with Excel obviously will be good for many, many assignments, not just in math. So the more familiar you become with Excel, the more you'll be able to find uses for it. I find uses for it all the time in my daily life and everything else. So anyway, let's go back and let's take a look and just copy and paste whatever histogram tool you use, copy and paste it there. Again, I suggest not using the applet. That's the Desmos applet that they provided. Okay, number 3, generate a box plot of the state data in the column titled % of total population using the Box Plot Applet. So in this case, using the applet's actually really good. I would say the applet is the best thing I found for this one. And what you want to do is just delete this and put in the data. Should say 52 elements if you did it correctly. And that should produce it. And there you go. You might have to zoom out a little bit. You could just scroll out and it'll zoom out a bit. Okay. And you could see that, this right whisker up to the max is all the way over here because there's one value that's all the way up to 99. So because of that, it makes this right whisker very large, right? Because there's outliers over there on the right. So you can go ahead and grab this and you want to put it in there. Paste and attach image. No, okay. There you go. And for number 4, it says describe the shape, spread, and skew, if any, of the data. So thinking about those 2 graphs we just made, the histogram and the box and whisker plot, does it seem symmetric or not? Well, in this case, it's definitely not symmetric, right? You saw that one whisker way off left, or sorry, way off right. Or looking at the histogram, we could see it's skewed to the right. You could see that because there's outliers out here to the right. Another way to think about it too is that, is this thing, so talked about its skewedness, we talked about its spread a little bit so that you can see that the data points that are on the higher end are far more spread out, which it gives it that long whisker. Yeah, so I just explained that there. Examine the graphs and the information provided by 2 applets, record the mean and median. So if you have Excel, then calculating the mean and median is very easy. So what we want to do is I've already have my data here selected. And what I could do is maybe to the side here, I could write mean and median. And I could just calculate equals average. So mean is the same as average. Click here, Control Shift down, enter, and there you go. We can go ahead and calculate the median in a similar way, equals median. Click here, Control Shift down to select all the whole column, close parentheses, enter. So now we can see we have the mean and the median just like that. So there you go. By the way, if you have Excel, please follow along. This is very useful information. So you have the mean and median, the data set. Return to the Box Plot Applet, exclude outliers, and then click Update. So here we have that Box Plot Applet. It says there's a thing where you could say exclude outliers, but I don't see that anywhere here. I don't see any way to exclude outliers. So I don't really know what they're talking about, but we can still exclude the outliers, and I'll show you how. So if you have Excel, first we need to find the outliers. Now, if you remember, there's a formula for outliers. First thing you need to do is find the IQR, or the inner quartile range. So you need to find Q1 and Q3. So how can we find that using Excel? It's actually pretty simple. So first, let's find Q1. Now, the way you're going to do that is you put equals, and then you could put quartile, and you can just click on quartile here. And we want this array, Control Shift down to select the whole thing. And we want quartile 1. So let's close that, enter. So you can see the quartile 1 is 4.35. Now we need to find Q3 as well. So we find Q1 and Q3, subtract them to find the inner quartile range, or the IQR. So then let's go ahead and find Q3. And it's very similar. You put equals quartile. Whoop. Double click. Again, select the same array, Control Shift down. And we want Q3. So put comma 3, enter. And there you go. So we have our Q1 and our Q3. So how do we find the inner quartile range, the IQR? Well, you simply subtract Q3 minus Q1. So we're going to put equals Q3 minus Q1. There you go. So we have the inner quartile range right there. Then what we need to find next is we want to find 1.5 times the IQR. So this is how you find outliers. So we need to know 1.5 times the IQR. So we're going to do equals 1.5 times the IQR, enter. So 12.3 is the 1.5 times IQR. Now what we want to do is anything that's 1.5 times the IQR below Q1, or 1.5 times the IQR above Q3, those would be considered outliers. So let's go ahead and I'll show you what I mean. So we would do 1.5 times the IQR. So it'd be Q1 minus 1.5 times the IQR. So equals Q1 minus 1.5 times the IQR, negative 7.95. So any value that's negative 7.95 or lower, those would be considered outliers. Okay. Now, obviously, we don't have any negative values in our set, so we don't have any outliers on the lower end. But let's see if we have any outliers on the higher end. You kind of should already know that we will have an outlier, at least one outlier on the far right end, because looking at this histogram, we can see this one data point right here is definitely an outlier, right? So let's go ahead and see if we have how many outliers we have here. And the way you do that is you do Q3. Where's Q? Q3 plus 1.5 times the IQR. So here we're going to put equals, and I want Q3. So I'll click on that cell right there. plus 1.5 times IQR. Click on this cell right here. So 24.85. So any amount that's 24.85 or higher are considered outliers. So let's go ahead and look at our data set and see if we could find any outliers. Yeah, we could see some right here. So like 29.6 is an outlier, 37.6 is an outlier. There's a quick way to go ahead and find our outliers. One thing is you can go ahead and select this column again, Control-Shift down to select all the values. And if you right click and you click go to sort, smallest to largest, and it'll sort them just like that. So now it's easily sorted. So that's nice there. Now, if we scroll down, we can see the outliers down here. So these are outliers because these are values that are larger than 24.85. So 26.5, 29.6, 37.6, 37.6 again, 46.3 and 99. These are all our outliers. So what we want to do is we're going to go ahead and select this column, but we're not going to select our outliers. So go ahead and select everything besides the outliers. We're going to copy. Then when we go to the applet, we're going to delete our current list and put in our new list without the outliers. So now we can see our box and whisker plot right here. So this is the new box and whisker plot that excludes the outliers. Okay. All right. So we excluded the outliers. Notice the boundaries contact with outliers showing a small, okay, blah, blah, blah. Based on this plot, how many outliers were there? So we could see how many outliers were there. 1, 2, 3, 4, 5, 6 outliers. 6 outliers. Okay. Which states were outliers? So to find that information, we go back to this right here, and I want you to locate each of the outliers. So for example, 29.6 was one of the outliers. Which state was that in? Arizona. Okay, so we can see that row right there. What's the next outlier down? So right here, California. So 37.6 was an outlier, and that's for the state of California. And just scroll down and look at all the different states that are outliers. So I want you to list out all the states that are outliers in that problem. So right here, so you list out Arizona, California, and the other outlier states or territories. So anyway, once you do that, you want to look at the states and see if they have anything in common. So as you can guess, California, Arizona, probably some of the other outliers are going to have a border with Mexico, probably. And California, Arizona, they both have a border with Mexico, which makes sense why they have a larger Hispanic population. See if any of the other outliers follow that same pattern, and that's something you can comment on. Okay, let's go to the next task. Diamonds. If you were in the diamond business, or if you are looking to purchase a diamond, you need to know how to price diamonds accurately. Otherwise, you would be losing money by selling too low or losing customers by selling too high. They use the wrong two here twice. It should be T-O-O. T-O-O. All right. Having some sort of price ruler can be very useful. In this task, you will examine data for the most extravagant diamonds on the market and begin building a price ruler. Okay. Read about the 4 C's of diamonds: cut, color, clarity, and carat weight. You don't have to do that. For some background information, then look at the trends of pricing of diamonds that have blah, 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 blah. Okay, good. What you want here is click on this data. So it's going to open a new Google Sheets with this data right here. Diamonds of 1+ carats that have a VVS1 clarity, 2012 data. Okay, And we're really going to just use these two columns here, carat and price. So carat is the weight of the diamond, and its price obviously is in dollars. Okay, so you can see there's various prices here, sizes, whatever. Okay, great. So first thing we want to do is generate a scatter plot of the weight versus price for the diamonds using the scatter plot applet. So again, the scatter plot applet is not good. So I would not suggest using that. What I would suggest is, once again, you can use this linear regression calculator. This is on social science statistics. If you put in linear regression calculator, it should be one of the first things that come up. Also, there should be a link in the description, so you can use that as well. But basically for the X values, you want to copy this column here for the carat. So Control Shift down to select just that column, copy, and then paste in for X values, then do the same for Y values. Then you want to go to calculate regression equation, and it'll produce, just like you see here, we could see the scatter plot, and you could see the linear regression equation. You can see it's right here. Y hat equals 71761.97x minus 67254.54. Okay, and you can see the scatter plot as well as the linear regression line. Okay, now if you have Excel, I would suggest doing it there. So how would I use Excel to do that? Well, let me open a new sheet. And I'm just going to go ahead and grab these two columns here. So I could select these two, Control Shift down. Yeah, that didn't work. Just select these two columns. Okay. Copy. And put it in Excel. Paste. Okay, so now I got these two columns. And what I want is a scatter plot. So select this, these two columns. I just selected the first row and then put Control Shift down, selects the whole list of data. And then we want to go to Insert. And what we want to do is a scatter plot. So you can go to Recommended Charts, go to Scatter Plot, and it'll produce a scatter plot just like that. Now, the other thing it needed was the linear regression line. So if you have the scatter plot like this, you can go ahead and click on this plus, go to trend line down here, click on that, and it'll produce the trend line there. If you click on this arrow, you go to more options, then go over here. We want linear, and then we also want to display equation on chart. So go ahead and click on that, and it'll display the equation. It should be the same equation that we saw from that website. Notice it's the same slope and y-intercept there. Y equals 71762x minus 67255. So it should be the same scatter plot, the same linear regression line, all that. Okay. Again, take a screenshot, put it on there, and that should all be good. Okay. Okay. Describe the relationship between the price and weight. So we saw the scatter plot. Is there a correlation there? So is there a positive correlation between the price and the weight? Is there a negative correlation, or does the data seem random? Well, hopefully you should see you should state that there's a positive correlation, because as the weight goes up, we've noticed that the price goes up, which makes sense, right? And you can see that when we look at the scatter plot here. As we see, the higher the carat or the higher the weight, you can see the greater the price, which makes sense because it has a positive slope. As one variable increases, the other one also increases. All right, return to the scatter plot applet. Okay, click the line of best fit box, click update. So the regression equation is the same equation we just talked about. So that's the 71762x minus 67255. Okay. Now it also asks for the correlation coefficient. So one thing to think about is the correlation coefficient is also use the variable r. So Can I do that in Excel? Yeah, I can. So what you want to do is you go here, again, go to this plus, go to trend line, go to this arrow, go to more options. Then if you scroll down, you could say display R squared value on chart. Go ahead and click on that, and you should see this R squared value. Okay, it says R squared is 0.8784. Now, in order to find the value of R, the correlation coefficient, is you need to square root that value. So with our calculator, I'm going to do the square root of 0.8784. And I get a correlation coefficient of 0.9372. Okay, 0.9372. Now you could also get it from here. Here it gives you, does it give you the correlation coefficient? I'm not seeing it. That's okay. We have it anyway. Okay. So yes, take the square root of this R squared value to find the correlation coefficient. The strongest correlation, by the way, is a correlation of 1. So if you have a R value of 1, that implies that there's a perfectly straight line correlation. Is this perfectly straight line correlation? Well, no, because you can see a lot of the points, some of the points are very close to the line, which is good, but some of the points are a little bit far from the line. So it's a pretty good correlation, I would say. Like a correlation of 0.937 is a pretty strong correlation. And you can see the line is very close to these points for the most part. But it's not a super, super good correlation, I would say. Especially when you look farther down the line, like farther to the right, you can see many of these higher end diamonds are far away from the linear regression line. Okay. So is it a good fit for predicting the price of a diamond? I would say it's a fairly good predictor, at least for diamonds that are on the lower end of this data set. Using the equation for best fit line, estimate the price of diamond weight weighing more than 3.5 carats. So what we're going to do here is, let me just grab this here, and our linear regression line again was 71761.97x, y equals minus 67254.54. Okay, now how do I use this linear regression line to help me predict a price or the estimated price here? So that's what we need to find. Well, I'll show you how to do one of them and you can do the others. Basically, you take this, this weight right here, which in this case, for this first one is a 3.64 carats. Here it tells you the actual price, which is 254,000. I couldn't imagine spending that much on a diamond or anything besides like a house, but apparently that's how much it costs. So some people got some big money. Anyway, so let's go ahead and take this weight and we're going to replace X with that value, and then that'll help us estimate what the price should be. So let's do 71761.97, then replace X with this weight. So 3.64. And then we're going to minus 67254.54. Okay. So here's where we're going to use our calculator. 71761.97 times 3.64. Okay, then minus 67254.54. Okay, I got 193,959.03. Okay, so what does this tell us? Well, basically our linear regression line says that this diamond should cost about 193,000, okay, or 194,000. The actual price you can see is much higher than that, which kind of makes sense because when we look at our linear regression line, these data points on the far end are above the estimated regression line. Okay, so the regression line is not a very good predictor for these higher end diamonds or higher weighted diamonds. Okay, hopefully that makes sense. I want you to follow the same process for calculating this estimated price amount for these other two weights of diamonds. Okay, once you're done with that, let's go ahead and move on to number 12. The regression equation you obtained in part 10 is a linear equation, right? It produced the line of best fit. However, the actual data values do not seem to fit a linear shape. There is an upward curve, right? And you could see that when we look at the scatter plot. You see the data points are kind of curved up here, right? Another option is to use a different shape of regression equation that might better fit the data. Return to the scatter plot applet. We're not going to use that. Click the custom fit box. There is no custom fit box. That's why we're not going to use it. And then click update. Notice the graphs of the quadratic curve shown in the green. Okay. So here we're going to make a quadratic of best fit. So instead of a line, it'll be a curve of best fit using a quadratic equation. So how do we do that? Well, if you have Excel, once again, you could just go back to this chart, click on the plus, go to trend line. Over here, we're going to go to more options. Then click on these bars here. Go to polynomial, click on polynomial. You want order 2 is what we want. And we want to see the equation. We also want to see the r squared value. Okay, go ahead and click that, and this should pop up. Okay, so now let's go ahead and move this over here. And you can see this. I'm going to maybe change the color on this. Color. Let's make it black so it's easier to see. So you can see this black curve here better fits the data, especially these higher end diamonds. This curve is more close to these other, to our data points, right? It more follows the trend of the scatter plot. And you can see that's shown here by a larger correlation coefficient, right? Notice its correlation coefficient, or its r squared is 0.9693, which is higher than this one's r squared, right? The linear r squared. Okay, so how do we calculate the correlation coefficient? Well, once again, we want to take the square root of that r squared. So we're going to do the square root of 0.9693. So that'll give it an r of 0.9845, which is a very strong correlation coefficient. You can see all the points are very close to this curve. Remember, the highest a correlation coefficient can be is 1. So a correlation coefficient of 0.9845 is really close to 1, right? So it's a very strong correlation, we would say. Yeah, so go ahead and state that correlation coefficient and state that because the correlation coefficient is closer to 1, the curve is a better predictor of the price of the diamond. Using the equation for the quadratic curve, estimate the price of diamonds weighing more than 3.5 carats. So once again, we're going to use this information here, except for our estimated price, instead of using our linear equation, we're going to use the quadratic equation. So I'm going to delete all this. Delete, delete, delete. And we want to use that quadratic equation that we just found. So what was the quadratic equation? Let's see, it was y equals 18128 x squared minus 9347.5 x plus 4874.4. Okay. By the way, if you don't have Excel, you can take screenshots of this video and put that if you need to, if you really need to. Okay. So again, my equation was y equals 18128 x squared. So instead of x, I'm going to put this value here. It's weight. So 3.64. And this is squared. Let's move my face here. Okay. Then minus 9347.5 x. And once again, I'm going to replace the x with the value there. So 3.64. And then plus 4874.4. Okay, so now we're going to work this out. So how do we do that? Well, the first thing I would do is I would work out what this 3.64 squared is, right? Remember, we do exponents first. So 3.64 squared, and then times 18128. I got 435390149. Okay, but then minus, then let's multiply these together. So I've got 9347.5 times 3.64. So minus 340 to 4.9. This number seems a bit too large. Am I missing something? Did I write my equation correctly? 18128. 18128 x squared. Let me double check that. What is this number? This number is in the 4 billion range. That doesn't make much sense. 64 squared times 18128. Okay, yeah. I don't know where I got this number from, but it's not right. Okay. Good thing I double checked. So 240,188.75. Then we have this, and then plus 4874.4. So then we're going to do this first number minus this number, then plus this number. So minus 340 to 4.9, and then plus 4874.4. So this gives us an estimated price of 211038.25. So you can see this value is much closer than what we got from the linear equation, right? Much closer to the actual price than the linear equation gave us. So do the same thing for these other two values. So we're going to put 4.51 into this, just replace these values for 4.51, calculate it out. It should be fairly close to the actual price. And do the same thing for the last one as well. Okay. So is the quadratic curve a better fit predictor? Yes, and that's because it's correlation coefficient. Which curve produces the better estimate? So you should see that the quadratic regression is a better estimate for the actual price of those higher end diamonds for sure. Okay. Well, I hope that made sense. If you have any questions, then you can comment them below. And thanks for watching. If you liked the video, then please like, comment, subscribe. and share it with someone else who might find it useful, a teacher or another student. But anyway, take care, guys, and I'll see you guys next time.